All right, so we got kind of a lot to go through, so be sure that you're stopping the video to work problems out and try yourself and fill in what you can here. So, all right, let's rock and roll. All right, so we got the equations for lines for slope intercept, point slope, and standard form. So the three different types of forms for lines, and you're going to have to be familiar with solving using any one of them that is being asked. And sometimes you're going to need to use more than one in order to actually answer the question that's being asked. And so, what are the intercepts? Okay, so intercepts are where the line crosses the x or y axis. All right. So x-intercept crosses the x, y does the y. All right. And so we'll see with the x-intercept, okay, we might call this A and 0. For the y-intercept, we're going to call this 0 and B. Now you might wonder what the A and B is for. That's for these different forms for the line. So the first one we're going to do is known as the standard form. Okay, and so it looks like A, and there's that A we were just seeing, plus BY equals C. Okay, so this is where A, B, C, none of these, all right, so they cannot be fractions or decimals. Okay, and always make A positive. All right. So we'll get some examples further on, kind of showing what this actually looks like. But an example of what this could be is something like 3x minus 2y equals 6. Okay, so even though the form, the ax plus by, it could be a minus in there as well. So that doesn't change what it is. All right, so that's standard form. We'll change colors here. The next one is the point slope form. And so you're going to use this one often, so get familiar with it. So it's y minus y1 equals mx minus x1. All right, and so m is the slope, and the point is your x1 and y1. Okay, so that's why it's called the point slope. You need a slope and you need 1 point in order to do this. So let's say we had a slope that was equal to 2/3. We'll say negative 2/3. And we got a point that has the coordinates -4 and 3. All right, so I got a point, I got a slope. How would I put this in there? Well, I got a y minus, and I put in the y value in the point, and that's 3, equals the slope, which is negative 2/3, times x minus whatever my x value is, which is -4. So I put it in there, minus the negatives, so technically it would be x plus 4 would be fine. But that's how you take a point and a slope and plug it into that form. All right. So let's do some green here. All right, I got the slope intercept form. Okay, and so this is maybe what you probably remember most. That's your y equals mx plus b. All right, so again, m is your slope. Okay, and then you got the y-intercept is going to be 0b. All right, so the x has to be 0, and then b is whatever value that is. That's where the line would cross the y-axis, which is why it's called the y-intercept. Okay, so if I had a slope that was equal to 1/2, okay, and a y-intercept that is 0 and -3. Okay, now plug this in. Y equals 1/2 x minus 3. Okay, so that would be my slope-intercept form with the slope and the y-intercept. Okay. So those are the three types we're going to be applying here in just a couple of minutes. So one cannot use the standard form to write an equation. Okay, so you're going to have to use the point slope, okay, the y-intercept method first, and then change it to the standard form. Okay, so if a question asks you to write it in standard form, you can't just make that equation up. You're going to have to use the point slope or the slope-intercept form and then be able to adjust it to the standard form, which we will do practice on that. So you'll see what I mean in just a minute. Okay, so just a couple things about vertical lines and horizontal lines, right? The equation for a vertical line is x equals a, where a is the x-intercept, so wherever it goes through the x-axis, okay, that is a vertical line. So remember, all right, that would be, all right, the slope is undefined because I can't, on a slope, divide by 0. I can't divide by nothing, so it's technically undefined. You'll see it as a vertical line on the graph, but technically the slope is identified as undefined. And so we could write something like that, right? The equation for a line that passes through, just x equals 6. So that is the x-axis coordinate. And so that would be where it would go through because it's a vertical line. It'll eventually go through the x-axis. All right, horizontal line is different. This is where y equals our b value, which means there's going to be a horizontal line. And so in that case, okay, the slope is equal to 0. Okay, and so I could write that out as y equals -3, because I would go maybe down to -3, and then every value horizontally that is at y equals -3 would be on that slope. And so if I was given this point, okay, then I could use the point slope, okay, in order to see this as well. So y minus y1 equals mx minus x1. All right, so if I just plug in the coordinates there, so my y value is -3. I got my m, which I don't know what that is. And then I have, well, actually, sorry, that is going to be 0 because my slope horizontal line is 0. And then x minus 4. Okay, so we end up getting the right side. 0 times anything is 0. Y plus 3. If I rearrange, it'll be y equals -3. Okay, so just showing how I could use a point, plug it in there, and I would get the same thing. Okay, looking at this. All right, so it says write the equation for a line whose slope is 1/5 and y-intercept is 7. Also write the equation in standard form. All right, so I'm given a slope, I'm given a y-intercept, so I'm going to use the slope-intercept form because I got everything that I need for it right now. And so again, that is y equals mx plus b. So I'm going to have y equals 1/5 x plus 7. So that is my y-intercept form. Okay, and so now, if I have this form and I'm needing to go from here, and this is how you're going to go from one form to another. So I got to start with a form and then convert it to the other type of form. So I got to start with this one if I'm going to convert it to standard form, which, reminder, that is ax plus by equals c. And so if I have ax plus by equals c, I got to rearrange this to make this actually work. Okay, but remember, in standard form, I cannot have a fraction or decimal, so I need to somehow get rid of this 1/5. Well, in order to do that, I got to multiply each side by 5, because I'll get 5 over 5, which will get rid of the fraction, just leave me with x. So I'm going to multiply each side by 5. So I'll get 5y equals 5 over 5x plus 35. Okay, so I got to get the x and y's on the same side, and so I'm going to subtract this x from each side, and so I'm going to end up with negative x plus 5y equals 35. Okay, and so now I have it in standard form. Now, technically, I'm not supposed to have a as a negative value, so I'd multiply everything by -1 on both sides to get x minus 5y equals negative 35 would be my final. Okay, so I had to start with slope intercept and then convert it to the standard form. All right, so write the equation of a line that contains the point 0, 4 and has a slope of 1/2. Well, if I look at the problem, I see I got a point and I have a slope. That tells me exactly the type of form I'm going to need, so I'm going to use the point slope form, okay, which is my y minus y1 equals mx minus x1. Okay, so that's the form. I'm going to plug the values in. So we got y minus 4 equals 1/2 x minus 0. So I plug that in, okay, and I have my value. So if I needed to convert that to a to like slope intercept form, okay, so let's say I was going to put that into slope intercept form. All right, then I would just y minus 4 equals 1/2 x, right? Because then 1/2 times 0 is 0. I would add 4 to each side. And so I can see how I can easily transfer from one form to the next if I wanted to. Okay, which you'll be able to do on some of these other ones. Okay, so find the slope and y-intercept. Okay, answer as a point. Okay, so that means just putting the y-intercept into its actually coordinate with an x and y coordinate of a line whose equation is 3x minus 5y equals 15. Okay, reminder, what form is that in? Hopefully you realize that is the standard form. Okay, so I'm going to take standard form and I have to rearrange it into its slope and then intercept form. Okay, so that'll give me what I'm looking for. So remember, slope intercept is y equals mx plus b. Okay, so I'm going to take my 3x minus 5y equals 15. I'm going to rearrange it for y. Okay, so I end up with negative 5y equals negative 3x plus 15. I'm going to divide by negative 5 on both sides. I'm going to have y equals 3/5 x minus 3. Okay, so I divided each part individually by negative 5. Okay, and so now, well, what is my slope? My slope is going to be 3 over 5. And my y-intercept, okay, remember the b portion here is the y-intercept, but that's the point. So to do a y-intercept is always 0, and then the b is the second number, so it'll be 0, negative 3, how I would answer that as a point. Right? Okay, so find the equation of a line that passes through 1, negative 2, and has a slope of 3 in point slope, standard, and slope intercept form. Okay, so this is going to take a little bit of work, but I got to try to figure out, well, which one do I start with to help me convert to the others? Well, like I said before, point slope is going to be your best bet to start and then be able to convert to the other ones. And we also have a point and a slope, so that helps me figure out which of these I start with. Okay, so my point slope, right, remember, I'm going to repeat this over and over until it's drilled into your head, okay, what each of these are. All right, so then I got y minus negative 2 equals 3 times x minus 1. So I get y plus 2 equals 3x minus 1. So there's my point slope form. Now, if I'm going to try and get slope intercept form, okay, I'm going to take that, y plus 2 equals 3x minus, I'm just distributing a little quick. Okay, then I would get y plus 2 equals 3x minus 3. Okay, I would subtract 2 from both sides, and I get y equals 3x minus 5. Okay, that is my slope intercept. Okay, so just want to make sure that I'm going to clear what those are. All right, so if I'm going to go into standard form, I could go back to my point slope version of this. Keep it right there. Okay, and I'm going to just have this distributed because I'm going to need to do that anyway. Okay, now remember I got to have AX, BY, and then the number by itself. So I'm going to rearrange the opposite direction. So I'm going to end up adding 3 to both sides. I'll subtract y from both sides. All right, so kind of doing 2 at a time. 3x minus y. So I can write it as 3x minus y equals 5. And that is my standard form. All right. So you see how, all right, you go from one to the next. Okay, but point slope is usually going to be the place where you start. Okay, so write an equation of a line that contains the point and the slope. Okay, which should I start with? Got each of those, so it's going to be the point slope. All right, so I'm going to have y plus 5, because it's minus negative 5, equals 4/3 x minus 2. Okay, that is the point slope form. And so write an equation that contains the line. Now I'm going to rearrange it into a kind of y equals. All right, so I got a y plus 5 equals 4/3 x b minus 8/3. Okay, so then I'm going to subtract 5 from each side. So I'm going to get y equals 4/3 x. All right, and so I got 8/3. So I got to figure out, well, what is 5? 8/3, that's going to be minus 8/3, and then minus 15/3. All right, because I got to have like denominators in order to combine them. So simplified, 4/3x minus 23/3. There's a bad 3. 23/3. Okay, so that would be my y-intercept form. All right, so I got my y-intercept form, or my slope intercept, I should say. And then I got my, I guess technically, I guess to right here is my point slope. Okay. All right. Last one in this section, find an equation of a line that contains points -2, 1, and b in the most convenient form, and then in slope intercept form. Okay, so anytime it's the most convenient, most likely it's going to be point slope form. But in this case, we do have 2 points. Okay, so what I should do is immediately find the slope. Okay, so the slope that we've already gone over how to solve that. So it's delta y, it's change in y over change in x. Okay, so I'm going to have 3 minus 1 over 2 minus negative 2. It's going to be 2 over 4, which equals 1/2. All right, so that is my slope. And so now I could do the point slope. Okay, so I'll have y minus, we'll use point B, y minus 3. It doesn't matter which one you use. 1/2 x minus 2. All right, so I end up with y minus 3 equals 1/2 x minus 1. I'm going to add 3 to both sides. I get y equals 1/2 x plus 2. And that is my slope-intercept form. All right, so it's good to see this, that you're going to use that more often than not, but not every single time. Okay, we're going to keep going on to this set of notes. All right, so quick review of this stuff. We got our standard form. All right, my ax plus by equals c. It could be capital B, lowercase b. Doesn't really matter. All right, so remember, no fractions. Or decimals. A is always positive. Okay. All right. Then I got my point slope. That's going to be my y minus y1 equals my m, x minus x1. All right, so we need a point, and I need the slope. That's the point slope. And then I got my slope intercept form. This is my y equals mx plus b. All right, again, m equals my slope. And so I can plug that in for each. All right, remember, slopes of parallel lines are equal. Okay, and then slopes of perpendicular lines are opposite reciprocals. All right, remember, reciprocal, if I had, 1 over 2, okay, the reciprocal is 2 over 1. You just flip them. It says opposite means that if it's positive, it'll be negative, and if it's already negative, it's going to be positive. All right, so let's apply some of this. All right, so write an equation for the line that is parallel to the line AB that contains point C. Okay, so you're given the slope-intercept form, 2/3 x plus 5, and you're given a point. Okay, and so I can look and see that my slope of AB equals 2/3. Okay, and then my slope of my parallel line, whatever that is also going to be 2/3. All right. And so now I'm given a point on that line, so I could just use my point slope form, which is my y minus 5 equals 2/3 x minus 3. All right, so I've plugged that in, and that is my equation of the line, point slope. All right, so write an equation of a line that is perpendicular to AB. All right, so I got the same equation that I had. I got a different point now. So my slope of AB is still 2/3, but now try to write in what the slope of the perpendicular line is. Remember, it's the opposite, so it's positive. That means it's going to be negative. And then reciprocal, so it's going to be 3 over 2. All right, so same type of thing. I have a point, I have a slope now. So I could use the point slope to get y, not equals, sorry, that's a different one, y minus y1, which is 1, equals negative 3/2 x plus 3. And it's x plus 3 because it's going to be a minus a negative 3. All right, so that is my equation of the line. All right, so write an equation for a line that goes through 5, negative 7, and is perpendicular to the axis. Okay, so if it's, to the x-axis. So if it's perpendicular, if I had, just to kind of get a visual, if it's perpendicular to the x-axis, hey, what type of line is that going to be? It's going to be vertical. Okay, so what do we know about a vertical slope? Okay, that is undefined. And we do have an axis, or we do have a point. And so just going through the x-axis, we're going to go 5, and negative 7 will be down here. And so the actual equation for that line is x equals 5. Okay, so any coordinate that has x equals 5 will fall on that line. All right, because it's perpendicular to the axis. All right, what about a horizontal line that contains negative 312? All right, so it's a horizontal line. Okay, then again, if we drew a quick graph, horizontal line that goes through negative 3 would be down below here. Actually, no, that's not true because it's negative 3. Okay, then 12, and so it would actually go through a line here. Okay, and so where's that line? Where does that go across? Well, that's going to be, again, having slope of 0, but then the equation is going to be y equals 12. Okay, and so just to prove that to be the case, we know horizontal line is 0. I could do the point slope, and so my point, y minus 12 equals 0 times x plus 3. Well, 0 times x plus 3 is 0. If I rearrange this, I end up with just x equals 12. Okay, so it's the same thing. Okay, this is a fun one. A perpendicular bisector of a line segment with endpoints 5, negative 2, and 7, negative 4. All right, so on something like this, what I would recommend is to do a bit of a drawing. Okay. All right, so it's got endpoints of 5, negative 2, and 7, negative 4. So I can make this one 5, negative 2, and make it this one 7, negative 4. Okay. And so I'm going to have something that will create perpendicular, tells me it's going to be a right angle. But bisector, okay, means, okay, that it's going to be through the midpoint. So when it's through the midpoint, that tells me, I'll use some green, that this and this are the same. All right, so I'm starting to visualize what we're talking about here, which is really, really important. All right, so I need to figure out a few things. All right, first thing is I have 2 points on the line, so I can figure out the slope. All right, so I got 2 points, so we'll do negative 4 minus negative 2 over 7 minus 5. So that becomes plus 2, so it's negative 2 over 2, so it equals negative 1. So that's my slope. Okay. Now, so my slope of that line is negative 1. So what's the slope of the one perpendicular going to be? It's just going to be, the slope of the perpendicular will be the opposite reciprocal, which just becomes positive 1. In this case, 1 over 1, the reciprocal is 1 over 1. Opposite will be then positive. Okay, so now I have to figure out what the midpoint is. I got to figure out that right there because that's the point that I'm going to be able to then create with my slope to figure out what the equation for that perpendicular bisector is. So the quick review, remember midpoint formula tells me I take each of the x over 2, and each of the y over 2 to create a coordinate. All right, so if I look at x, I see 7 plus 5 over 2, and then I see -4 plus -2 over 2. So I get 12 over 2, which gives me 6. I get -6 over 2, which gives me -3. So the point that goes through the line is 6, -3. So with all of this, I can go and do y. I'll stay in green since it's kind of all related. I get y equals, not y equals, sorry, y minus, it will be plus 3, so this will be minus a negative, equals 1 times x minus 6. Okay, so that is what my equation for the line is. That's a perpendicular bisector of the line segment. All right, next one. We got that goes through -2, 7 and is parallel to the line 3x minus 4y equals 10, which is the standard form. So we're going to have standard form. We're going to then find out, well, what's the equation for the line that goes through -2, 7, and then we got to make sure it's in standard form. All right, so the first thing we want to do is solve. We want to solve for y to get slope. All right, so we got 3x minus 4y equals 10. So we're just going to rearrange. So I'm going to get 3x minus 10 equals 4y, and divide by 4 on each side. So I'm going to get y equals 3/4 x minus 10 over 4, or 5 over 2 would be fine. All right, so now I have a slope of 3/4. Okay, I have a point that it goes through it, so I'm going to use my point slope. So we got y minus 7 equals 3/4 x plus 2. Okay, so that is my point slope form, but it's asking for standard form. Okay, so I'm going to first, I got to get rid of that fraction. So what can I do? I can multiply everything by 4. And what I do to one side, I got to do to the other in order to get it to standard form. So this becomes 4y minus 28 equals 3 times x plus 2. So I get 4y minus 28 equals 3x plus 6. So I got to rearrange. So I want x to be positive. So I'm going to subtract 4. 4 from left side and right. And I'm going to subtract 6 from that. So it's going to end up being -34 equals 3x minus y. Okay, and I could just rewrite it so that's just like the other. Or it's 4y, not just y. Equals -34. All right, so that is in standard form what I want for my final answer. All right. Good job. Last one. A line that passes through points 5, 12 and -2, 4 also writes the equation in slope intercept form. All right, so I got 2 points. So I'm going to find the slope. It's going to be 4 minus 12 or -2 minus 5. So I got -8 or -7, which is 8, 7. So that is my slope. All right. Now I could just take any one of those points. It does not matter. We'll use the first one. So y minus 12 equals 8/7 x minus 5. Okay, so that is the point slope version of it, but it's asking for slope intercept form. All right, so all I got to do is distribute this out. I got y minus 12 equals 8/7 x minus, okay, I got to multiply this out. I get 40/7. Add 12 to both sides. That cancels. I get my y equals 8/7 x. But how am I going to add those things together? Well, I need a like denominator. So 7. So I can multiply a 7 and 12. I get 84/7. So we got minus 40 plus 84. And so I got y equals 8/7 x plus 44/7. And that is my final y or slope intercept equation. Okay, we're going to stop there. I wanted to give you quite a bit to be able to kind of chew on. You can go back and watch this as many times as you want to walk through the process, watch through different parts of it. But now you have enough that you can start working through your homework. And so if you're done listening to this and there's still class time left, start on your homework, work some problems out. If not, then you could be working on this over the weekend, which I expect you to do because we're getting through some of this, pretty quick, which is good. But I want you to get practice and be able to come in on Monday with any questions. All right, guys. Hope you have a great weekend. Thanks for listening. See ya.